Hi, mathematicians. We are going to continue our work with slope. After this lesson, you will be able to extend a table or a graph using rate of change or slope.
So we're going to follow the directions here, graph the points. These points are given as ordered pairs in a list, and they are given here in the table. These are the same points. To plot those points, -1, -2, that would be, remember, label your x and y axes. When x is -1, that's over to the left of the origin, and then y is -2, that first point is right here. At 0, -1, that would be right here. And 1, 0 would be to the right 1, but not up or down at all because your y is 0. So now it's saying, what is the fourth point? What is the fifth point? Fill in the coordinates in the table below. So we want to know when we're going further to the right, what is happening and how to predict that. So I like to use the slope that we've been talking about, or the rise over run. You can also figure that out by, doing your change in x and your change in y here and predicting, but I think it's easier if you're looking at your table. So if I go up 1 to the right 1, up 1 to the right 1, my next point should just be up 1 to the right 1 and hit right here. Make that a different color so we can see that better. And that point is 2, 1. So here it's asking, what is your method for finding the point? So if you're doing rise or over run on your graph, then you're going to describe that. Or if you're doing the change in y in your table and using that, you want to write that below. So you want to describe it in one of these two ways. I used rise over run to find my next point, up 1, right 1, like we did here, up 1, right 1. And to get that next point, you would go up 1 more and to the right 1 more, which would make that point 3, 2. Or you could have described this as I used the change in y and change in x in my table, and the change in y was 1 and the change in x is 1, and you can see that adding 1 to each of those gets those values. So I should see some work here. You should show me your rise over run on your table or in your graph. These little rise over run triangles here that would follow would be on your graph, and in your table you would just do their changes like you did in the last unit. Let's draw that line in because all those points fall on one line. When you graph your line, you should use a straight edge. It can be the edge of a paper. It doesn't have to be a ruler, but you want to really show that it goes through that and extend because that can help you predict further points. Find question 4. We got to remember that the rate of change is slope, which is m, as we see that in our description here. We start by graphing that point, 2, 3. After plotting that point, which was to the right 2 and up 3, because the x was 2 and the y was 3, let's label our axes. Always want to do that. Gives us a visual. So that's our point, 2, 3. The next part is telling us that the slope m is that variable, the change in y over change in x, is 3 over 2. What would the next point to the right of 2, 3 be? And so if you remember, rise over run, that's our change in y. So if our change in y is 3, we have to go up 3. Our 3 was positive, and when we have a positive number, you are moving in positive directions, which on your number line, up is the positive direction and to the right is the positive direction. If we had negative in our slope, we would have a down or left movement, but only one. So now we have to do our change in x, which is 2. So from that point right here, we need to go to the right 2 because that was a positive 2. And then our next point would be this point right here. And so looking at our x-axis, that's at 4, and our y-axis, that's at 6. So the next point here is 4, 6. Now, assuming the same rate of change of 3 over 2, what would be the next point to the left of 2, 3? And so if we want to go to the left from that original point right here, we have to go It's got to fall somewhere on this line. In fact, it can be helpful to draw in the line so you can kind of see that better. So if I draw in that line right now, you do the same. Connect those 2 points and let's see what happens here. Now it's a little easier to see where that left point is going to fall. You can see that to get to this line, we're going to have to go down first and then left in order to hit here. If we go up and to the right, we're going to keep going in the upper right direction. We need to go to get to the left. We're going to have to go down to get to the left. And it's going to be the same here. We're actually going to be going down 3 and then to the left 2. And those are both negative directions. So to see that on the graph, we're going down 3 and then to the left 2. But we still end up with this point on our line, which in this case, that next point is going to be 0, 0, or our origin. You can continue with this pattern of up 3 to the right 2 or down 3 to the left 2 and continue to hit on our graph. So down 3, left 2 would be here, down 3, left 2 would be here. They're all going to keep following on that line that I sketched in. A quick summary of what we've talked about in this lesson. Rate of change is also called slope and represented by the variable m. It is the change in y over the change in x, like we talked about in Unit 1, and it is also commonly referred to as the rise up or down over run. You always want to look at your slope from left to right, just like you would read a paper, words on a paper. So left to right, you're going this way. And then a positive rate of change is anything that is going up and to the right. So if you start all the way to the left and follow that, if your graph is going up at all, if your finger's rising as you go from left to right, if you're tracing it, that is positive. And for a negative slope, it is a line that is going down as you go to the right. And then always simplify your ratios and remember that one negative, this is a negative slope. It doesn't matter if that negative is in with the rise or the run or just out in front. If it's out in front, you can choose where to put it depending on whether you're going to the right or to the left along your line. And then if there's 2 negatives, it's the same as 2 positives, and that is a positive slope.